Hello, my name is Dr. Viktoria Gisladottir, and I'm a resource mechanical engineer at the Cold Regions Research and Engineering Laboratory. Here, I do work on resilient energy system in the cold regions. For example, I look at how to create sustainable and efficient energy in cold regions such as the Arctic, subarctic, and Antarctica.
And I'm Zody. I am a research mechanical engineer here at the Cold Regions Research and Engineering Laboratory. I also help on the resilient energy system projects, doing things such as putting together databases, helping with testing.
One of the technologies that we use to produce energy in cold regions is a wind turbine, and today we're gonna build a small-scale wind turbine. So we've taken everything out of the kit. We have the little bucket, the spool, the gears, the units that go with it, including washers. We have electric circuit. We have the motor here. We also have alligator clips. And then we also have screws, nuts, and bolts. And here is the base and the top unit. And then we have the blades, both balsa wood and cardboard. And also the supporting unit that are going to be attaching to the blades to the wind turbine. And then supplemental material, including a screwdriver, wood glue, and tape.
So I'm going to show everyone how to assemble the kit. If you need additional information, there is also a piece of paper that comes with the kit that will link you to some additional materials. So first, we're going to take the base and the base legs, and these should just slot right together. Now you have your fully assembled base, simple enough. Next, you're going to take the shaft, and it also just slots right into the base. After you're done with that, you need to put the top assembly together. So that's these I-beam shaped components. What you're going to do with these is slot them straight together, just like this, and then you should have 8 small screws that fasten it together into various points on the I-beam.
And we don't need to fully form them. It's okay if they stick out a little bit. If you do happen to have a better screwdriver than the one I'm using, you might be able to go all in, but given the screwdriver and the size of it and how it looks here, it's actually just more convenient to stop. And when you're screwing, sometimes you'll feel a little bit of a resistance, but it's okay if it starts sliding off to try one or two more times. And all right. And so what we have done here, I've already done one over here, I've done one here and one here, and I'm doing the final of the 4 that combine this unit. So after you put all 4 of them in, you know how I said you can leave a little bit of an edge here? It's nice to go back and then try more. Try one more time. See if it will allow you to go in a little bit further after the other ones are in. Sometimes the support of the other screw will allow you to more easily get it further. So here you can see the bottom screws are fully in. One of the top screws are here. One of mine is still sticking out. I'm going to try one more last time to see if it will go. And you know what? Once the other ones are in, that one actually comes all the way to the finished Now that we have assembled the top and the bottom, we're gonna go and attach here on the sides. You can see right here. And then I'm gonna go to the other side. And now that I finished the second one, I'm gonna go back to the first one and tighten it a little bit more. Before I place it on the top, actually, let's take each screw and we're gonna put it right here where the unit stand will go in. And we're just gonna put it here, but we're not gonna screw it all the way in. We're just gonna tilt it lightly. So that one, so it's lightly tilted, and then I'm gonna repeat the process on the other side. So you can see there's a decent amount of edge sticking out. All right, the screw is small and finicky, but we'll get there. All right, so now we have both of the screws sticking out. Then we can throw it on top of here, and once it's down, now we're going to tighten the screws to attach it so it's not going to move like this. Right now it can, but once we've tightened the bolt screws in, it's going to be attached to the base.
So next we're going to be putting together the top assembly that houses the engine. For this you're going to need 2 long bolts, 4 nuts, 2 wing nuts, and these little blue rectangular clamps. So you can put this on either side, it doesn't matter, you just need to ensure that you orient the additional parts like the blades and gears and motor all correctly. We're gonna go on this side. The bolts slot through holsters on the top assembly. It's a little tricky to put together, so I'm gonna do this one at a time. I would suggest holding the bolt up so that the bottom of it is in between the top and bottom of the I-beam. Put the first screw on. After the first screw, you need to put one of the clamps on with the smooth side facing down. That'll house the top of the engine. Next, we'll put the first screw on the other bolt. Now this is where it kind of gets tricky to slot in. I would suggest putting one side in first. You might need to move the bolt down some to fit it in there. And you'll have to manipulate the screw to get the bolt to move down. Next, we need to put our other blue rectangular piece on. So this will house the bottom of the engine, so make sure the smooth side is facing up. Jeez. Then we can put our last 2 bolts on. Okay, so now we can see that the assembly is secured in both slots. What we're going to need to do is move all the components on the assembly up far enough so that we can finish slotting the bolts through the bottom holes. And then once both screws are snug with the heads flat to the top surface, we can use the wing nuts to finish securing the assembly. Be careful you don't break it, but you're going to have to, don't be afraid to manipulate it around a little bit. And okay.
All right.
The next, it's just more awkward maneuvering to get the engine to fit in here, the motor.
Perfect. So now we're going to set up to insert the motor. But before we do that, let's do a little bit of a check of our work and do a little what we often call in the experimental word sanity check. So now that when we have done the sanity check, we're just going to remove the top, and we want the wing nut to be a little bit loose, so there's some mobility in the structure right here. And once we have that, we're going to take the motor and make sure the wires are facing down and the top is up, and we're going to thread it here through. And it doesn't have to be, but I would like the wires to face down. So once it's here, we're going to align it, and we're going to tighten the 2 smooth surfaces around the motor. And once that happens, we tighten the nuts around around the blue units. And you might need to hold the top of the bolt as you do it. And then first you tighten the top, and then you tighten the bottom. I don't tighten as hard as I can, but just enough so it's holding it. Then I flip over to the other side, and that's when I tighten the top. And here, you might just take your time and play around with it until it feels balanced on both sides and even. All right, so we have 3 different gears that we can use to run the generator. And then we have a supporting unit that goes on the motor. And then we also have these 2 units. And we have this unit as well. What we're gonna start by doing is we're going to start by threading this on top of here, and we're going to make sure that the smaller part of the unit faces this end. Once we have that, we're going to thread that through here, and then we're going to insert on the other end the same unit, and now the smaller unit is facing out. So in both cases, the smaller unit is facing away from the I-beam, and the larger flat unit is facing towards the I-beam. We insert the supporting unit on here, and we're just gonna press it on. All right, and then you can take each one of these gears and put them on, and based on which gear you put, you measure a different height of where you locate the motor. That's why it's movable. if you're doing this and you're gonna do all three, which I highly recommend, I would start with the smallest, go to the next, and then the third, and see the differences. Since we're only doing one today, I'm gonna start with the large one. And here, I'm gonna just hook it so there's a piece sticking out, and then there's the piece that goes in with two little ruffles here, and I'm gonna insert it so the ruffles link into the base here. So once I have these set up, you can align so these two gears interlace. Once they interlace, we can start stabilizing the motor. So you want to make sure that the surfaces align top and bottom, and then once that's happening, we can start tightening the bolts. And before you tighten one of them very tight, start by tightening all of them very loosely, just a little bit until it's just tilted against the blue units. Once you have them all tightened loosely, you can do a little bit of a sanity check and see if this moves and if the surfaces are in line. And then you can tighten even further. And just be careful that as you tighten, you want it to be tight enough to support things, but not so tight that it breaks. All right. All right. And at this point, we can actually put it into the base. So now you can take the balsa wood and the cardboard, and I suggest you take one of each and just feel the difference in the weight. And you can even look at it and see how the balsa wood, even though it is lighter, it's actually thicker. And if you want, you can even take and measure it. So this is going to be interesting later on when you experiment with a wind turbine to see how the different material affects the production. All right, and what later we're going to create turbine blades out of the full length of it. So take 3 of the balsa wood and set it to the side that we're going to keep for later, and then 3 of the cardboard and put it to the side for later. And now we're going to take the balsa wood and we're going to create blades that are smaller than the full-sized ones. Okay, we're going to take this piece and we want to cut it in half, and it's 12 inches, so we're going to run the edge by it to make sure our ruler is well aligned, and then we're going to mark it at different intervals. And then once we have the marks on the piece, we're going to create a line across it. And by creating the marks across the whole unit, it makes sure that the line is more parallel when the edge rather than if you just measure at one end. So now we're actually going to cut this in half. And if you are working with scissors, for example, you want to take a piece of the cardboard box. Maybe you can even use part of the box that this unit came in. And we're going to slide across the line. And as you can see, not much happened after I did that once. Then I'm going to repeat in the same track a few more times. And you don't have to put force. If you do force, you have a higher chance of not getting a smooth long line. But by doing it multiple times, you have more control. All right. And now we have 2 small turbine blades. We're going to repeat this process 2 more times so we get the 3 blades we need out of the balsa bolt. And then we're also going to do this for the cardboard. As it's thicker material, you're probably going to have to do more tries with the scissors, and that's fine. But one of the things when we're doing experiments, regardless or engineering or building, sometimes using finesse and taking longer and showing more patience is actually going to give us better results.
So next we need to put the turbine blades together. This is pretty simple. You'll need some kind of an adhesive, either wood glue or Scotch tape should work sufficiently. I'm going to use both just to kind of show you what to do. Then next you'll need a turbine blade and one of these wooden dowel rods that came with your kit. I would suggest attaching the dowel rod onto the back of the turbine blade where somewhere between a half to about 3/4 of the length of the dowel rod. So that way you have plenty of surface contact with the blade and it will stay. So next I'm going to add some wood glue to the center of the blade where I'm going to fix the dowel rod. So here, you kind of see the wood glue on the blade. Then fix the dowel rod to the glue like so. When you do this, I would suggest measuring and marking on the turbine blades, so that way you're perfectly in the center, and so that your blades are all the same length spoke. Next, I'm going to add some tape over top of it. So once you're done fixing the tape to help keep it in place, I would suggest waiting 12 to 24 hours for the wood glue to dry before you try to spin it on the turbine. And then do that for all of your turbine blades that you're going to be using. So it's been 24 hours and our wood glue is dried, so now we're going to go ahead and attach the blades to the turbine hub. So this is this little black component that came with your kit. There is a screw that's able to be rotated in the center of it that will loosen up the slots for the blade spokes. And I would suggest lining up your blades with each of these three little triangles kind of at exactly 1/3 of the way around the circle. So you want to keep the blades equidistant because it's going to keep the force balanced on the turbine, and that's going to increase your efficiency of the energy you're harvesting, and it's also going to prevent possible mechanical failures. In other words, if it's not equal and symmetric around the circle, your wind turbine is just not going to work as well. Then the other thing that's important to keep in mind is you're going to want your blades to be angled, because that creates the force imbalance that's actually going to allow the wind that's blowing straight at the turbine to rotate it. So once you have all your blades in their slots, you can go ahead and tighten that central screw. That way they're nice and snug in the hub. And then you can attach it to the front side of your wind turbine. Similarly to the back side of the central axis here, there are little slots that will align directly with the hub. You can slide it on there. And then there's a little screw at the top of the hub that you can tighten in order to mechanically hold it into place. So then finally, the angle that your blades are at are going to affect how the wind turbine performs. You can actually measure that with a piece that came with your kit. So if you just line that up perpendicular to one of your spokes, you can check the measurement, and we can see that this blade's at somewhere in between 30 and 40 degrees from the right angle. And similarly to before, how you want to make sure everything around the circle is symmetric because it's going to affect performance. That includes the blade angles. So if you have these blades sticking at different angles, or even you angle them in opposite directions, you could create a situation where you have an imbalance of forces that are trying to move your wind turbine.
We have the wind turbine now set up with the larger balsa wood turbine blades. We have the larger gear set up, and the engine, and then we have the motor here, and we have some wires sticking out. So what we're going to do is we're going to, for this part of the experiment, we're going to take the alligator clips, we're going to take the circuit board, we're going to take the black wire, or the alligator, we're going to take the black wire and the black alligator clip, and we're going to clip it on. And then we're going to take the red alligator clip and clip it onto the red wire. And just making sure that they're completely closed. So we take the alligator clips, we put it in the negative slot, and here we take the red alligator clips. So the black is negative and the red is positive, so we're going to just put it in right here. So now we have both of them clipped in. And what we're going to do next is I'm going to turn on this fan, and I'm going to turn it on first at the lowest level, and we're going to look how much voltage. And essentially the concept is that this fan is going to give off the equivalent of a wind, like when you're outside and you feel the breeze or actual strong wind. And the wind is going to move the wind turbines, which in then turn is going to move the large gear shaft, that is going to move the small gear shaft, that is going to turn the motor, and this motor is going to produce electricity. We're going to be able to see how much electricity it's producing here on the circuit board. So here at the top you have 1 volt, 2 volts, 3 volts, 4 volts, 5 volts. And the idea is that the higher the voltage number, the more electricity this wind turbine is producing. And today I'm going to show you production of electricity with the lowest speed of this fan and the highest speed. So you can see how as you increase the wind, the more electricity you're going to produce. Today in this video, we're going to show you a few different things you can experiment with, but that's not exhaustive list of everything you can do. You can also take the turbine and you can put it in front of a fan, but you can also go outside. And maybe you could even look at the weather forecast in the near future, and if there's a day that's going to be an unusually high wind speed for your area, but it's still dry, you might take it out and see the difference. And a really cool thing to do would be go outside on a non-windy day where it's very much stillness, and then go outside on a high windy day. And as a good experiment, what you can do is you can take your notebook with you, write the time of day you're going outside, the day you're going outside, and maybe even the wind speed. That's the weather stations that you can find online show that it is at that time. And you can write how much voltage came on your circuit board. If you want to be a very detailed scientist or engineer, you might say which gear. Was it the large, the medium, or the smallest gear you used? Or did you, what blades did you use? Which material and which size? And you could even in the same day, on the day that has little wind, you could try all 3 gears. And each of the gear, you could try it with the larger blades of the wood material, the smaller blades of the wood material, the cardboard large blade, and the cardboard small blades. And sometimes you might get the same values. And you can do this on, I highly recommend testing it on a low wind day and a high wind day. If you happen to live in an area where there just isn't really wind, or there's just always a lot of wind, maybe you can find a fan or some other place where air is moving and do this experiment in that way.
So energy can be hard to visualize sometimes exactly what it is, especially when it's coming in the form of electricity. So, I mean, obviously we can see it lighting up the LEDs, but you know, what does that mean? Well, there's an additional piece to the kit that uses this little wooden spool, a string, and a cup, and you can add weights to the cup. And we can use the same shaft that would be turning the gears to lift the string and the weights, because it takes energy to move weight through the air. So we're going to demonstrate that here. So you fill the cup with the washers that come with the kit to add some weight, and then depending on how fast the wind speed is and how much you can get the wind turbine to move, then it'll actually be able to use work to lift the cup. And if you really want to get into it, you can look up the fundamental equations and kind of measure out how much weight you're using and see exactly how much energy is being produced by the windmill. So as you can see, we overweighted the cup a little bit, and we had to turn the wind speed very high. And this is kind of sometimes what happens when you're engineering things. They go wrong, we run experiments, they break, things don't go how you expect. And particularly at high wind speeds, we would call that turbulence, and it can have these kinds of devastating effects on your engineering equipment. So now we're going to try it again with less weight and watch the wind turbine pick up the cup.